Hello and welcome back to an in-depth look at the DeltaMate fittings. In this video, we'll go deep into every single individual piece, a little bit about how it's made, why it was designed the way it is, and you can see how they're assembled, how to install them, and general applications of how you might use them in your custom loop. So here we can see the two types of tube fittings and all of their constituent parts, and you might notice there's less parts than there actually is in the fittings because the soft tube is comprised of two pieces. There's a barb and a compression ring. Meanwhile, the hard tube is made from three pieces. There's its base, a custom shaped O-ring, and this compression ring is the same one as from the soft tube fitting. So they're both for 60mm outer diameter, and they fit either the tube or the O-ring in slightly different ways. So the way the soft tube works is the compression ring first fits over the tube fits onto the barb, and then the compression ring screws around the barb to lock the tubing in place. If this was on a block, it would be easy to tighten it all the way, but just holding it in my hands, not so. And then the hard tube fitting is a little bit different because the base is completely flat and there's nothing that sticks up or engages with the tube in any way. That's deliberate. That's so that you can install the tube effectively from the side, and then it doesn't take any length to fit it in place. So you don't need to move the two components apart, install it and push them together. You can have them at a fixed distance, measure the distance, cut a piece of tube that fits inside, and put it in with both compression ring and the O-ring on both sides together, and then push them apart. The rubber actually fits around a little rim on here, a little base. So you can put that around there and it will hold the tube in place while you tighten the compression ring, and it also guides it onto the thread. And when it comes to engage together, the O-ring has to seal both against the tubing and against the base in order to seal the loop. And it does this with a domed edge on the bottom and a tapered edge on the top. The tapered edge is pinched by a tapered lip inside the compression ring, and that essentially pulls it together at the same time as the ring sliding the whole thing along the tube and against the base. So it forms two seals with a single rubber part, and that allows the fitting to be very simple. It's very small. The outer diameter for a 60mm fitting is extremely small because there's no metal on the base that surrounds the tube, just the rubber piece on all sides. And it has another surprising benefit in that you don't need to push the tubing through the O-ring when it's in place. You just put the O-ring around the tube. So the edge of the tube is not too important. It doesn't need to be perfectly chamfered. It doesn't need to be perfectly flat. And even if it doesn't penetrate all the way inside the fitting, it's still going to seal because this drops around the ring that's on the base and it doesn't sit above it. So when that's all tightened together, that's against the edge. It can't squish inwards underneath the tube. The tube just needs to be far enough in that the top of the seal has enough to grab, and then it will seal. So yeah, those three individual turned brass parts are combined to make the two tube fittings. Now let's take a look at the rotaries. So here you can see the two assembled rotary fittings. The first is a 90-degree fitting. It has a male thread and a female thread, and the second is a T-fitting. It has two female threads on opposing sides, so that you can use it to make a split in your loop if you would configure components in parallel or add in something such as a drain valve. You can put that to one side and continue the loop in series. So these also have little covers, and they conceal basically the internal part, which doesn't have any base sticking out. So you can't grab the base and install it like a conventional rotary. Instead, you use a hex key, and here we have a straight-ended hex key, which is what you need to use for this short socket. So that can be installed onto a block, And if you would try and tighten it like this, it just spins around the outside. You need to tighten it with the key, secure that, and then you can rotate it in both directions and it won't come out because it's locked by the key. One important thing to note is you can't use keys with a ball-shaped end because they won't reach all the way inside the hexagon. They might just engage with it, but over time you'll start to wear the very tip of the hexagon. So it's better to use a straight-ended key. You don't need to apply a massive amount of force, so again, you don't need one that's really long like this. We'll be providing these with our upcoming graphics card and CPU blocks, so there should be lots around. The next thing of note about the fittings is how they are built and assembled. So this is the exterior part. This part has the female thread, and this is the interior part. This has the male thread, and you can see how you're actually screwing it in. This part goes all the way through the middle, and when you turn the socket on the top, you're also turning the thread on the base. They're assembled like this, and they have 3 grooves. 2 are for rubber O-rings that provide the seal against pressure and coolant from leaking out. And the last one is for this steel spring. So that presses into the groove, and if you would then insert these 2 parts together, they'll get locked together by that spring. That essentially fits in a groove on the inside and the outside of the fitting. But for demonstration now, I'll show you what happens if you install these 2 parts freely without the locking ring, and then install another part into the female thread. That actually completely locks the base together. So mechanically, there's no way that you could ever pull them apart once they're assembled in a loop. Not that it's common that these would let go, but under extreme pressure that it might be subject to, it's conceivable, but extra parts, which must be installed to use this in the loop, come through the female part, and you can see when I screw that together, the male thread starts to stick into the bore of the outer piece and engages inside this slot, which is what's locking the 2 parts together. And the last piece that you can see here is the cover, which is again a turned brass part. This is a machine part, and that fits into the hexagon and basically just covers up the socket, and you have a clean top with a DeltaMate logo. The way these are made, they're laser engraved before the plating, so the logo is extremely subtle. You can just see it. It's like a black on black logo, just with 2 slightly different surface textures. It's done before it's plated. The plating is a chromium plating, and that's the same on every fitting. It's essentially a matte chromium that's colored black. So I think that's everything to see about the internals of the Rotary, but we'll get back to them later because it's very interesting how you can combine them with the extender fittings that we'll have a look at now. So here we have all 4 extender fittings and 2 90-degree rotary fittings, and I'll show all of the ways you can combine them to make other types of fittings. So the first and most obvious combination would be to add just a 7mm fitting to the base. And that's going to just make the rotary fitting a little bit taller. And with that extra height now, you could use that if you needed to clear, for example, a plug or any uneven surface, or just something that wasn't quite flat, like if a badge was sticking up, and when you rotated this over the top, you were going to have contact between the locking ring, perhaps, of a soft tube or hard tube fitting and the item that you're screwing it to. So these rotary fittings have a distance between the mating face on the female side and the male centerline of 10.5mm, and in the opposite direction from the mating face on the male side to the centerline of the female side is also 10.5mm, and that's the reason why you can assemble them into a cube such as that. Not that it has many practical uses besides being a huge and expensive cube. And when you have the 7mm installed, then the fitting is 17.5 millimeters in height from this new extended mating face to the female centerline. And that's very similar to a traditional 90-degree rotary when they used to be about this size. The female face doesn't sit out much, and it doesn't stick in, unlike others. So it's a very good usable rotary fitting. And then the next size, 10.5 millimeters, at first sounds like a bit of an irregular size to make an extender fitting, but it does have some practical uses because when you combine it with the 10.5 millimeter height of the rotary fitting, you now get an extended height of 21 millimeters from this mating face to this centerline, which is incidentally very similar to current 90-degree rotary fittings that are used by others. And so then you can use that combination to interchange it for use with distribution plates and other complicated loops. You basically get a direct replacement for other 90-degree rotary fittings. And then the 14, again, if it needs to be a little bit bigger, if you need clearance perhaps from a CPU block over memory or some such combination like that, the 14 is quite practical in between size. And then the biggest one, the 28, when combined with the rotary, means that you have then enough height for your tube to clear another rotary. And then the distance between these parallel tubes will be 28 millimeters, and that combines with other blocks, other distribution plates, whatever you might be joining together. Typically, that is the approximate spacing of the female ports on those. And also, the 28 millimeter extended fitting would be enough to clear fans. If you had a radiator and a fan sticking up next to it and you wanted the tube to pass directly over the top, then that's a very clean way to do it. Now we can do some slightly more complicated combinations. So let's start off by saying we have the 10.5 millimeter base. So it's the size and height of a conventional 90-degree rotary. So there's our 90-degree rotary to start with. If we install another one into the first one, now we effectively have an offset fitting, but it's not a fixed offset. It has two rotary points. So this can still be rotated on the product, and then you can branch off at any angle. This will be enough space for any other DeltaMate fitting to go here and still not conflict with the start point. So it's not likely that you would need to go back down further than you started, but you know, this has free rotation, 360 degrees all around, as does this joint. And you have an offset between this center line and this center line of 21 millimeters, which is quite practical. But further to that, because they're so small, you could also combine a 7 millimeter extender in the middle, all of which can be done with the one 8 millimeter hexagon key, because they all have 8 millimeter hexagon sockets. And now this combination has an offset of 28 millimeters. We can put that on our block here. And there you go. So depending on what you would want to do, maybe the 28 could have been there, and then it would be high enough to go up and around memory in this direction. You could make an opposing one on the other side, and any such combination. So you get to choose the height and the offset and the direction and this rotation with a massive amount of variables. So you can really assemble the exact fitting that you would want to have. All of the outside diameters of all of our fittings are approximately 21 millimeters. There are some differences. So for example, the round part of the extender and the back side of the 90 is 20.6 millimeters, and that's so that it has clearance for the next one to move past it. If you remember when we had two back-to-back like that, without the 7 millimeter in the middle, there's still space for them to go past each other. So that's where the 0.2 difference comes in. The nominal diameter of all of the parts is 21, and when a clearance is needed, then 0.2 is being subtracted. So 0.2 on both sides of the diameter makes it 20.6. Some parts, if you would measure them, for example, from the back of here to the front side, would be 20.8, because only this clearance is deducted, and this one is on the nominal 10.5mm space. And in that way, you can make a lot of different fittings. There's just one more to look at. And so here we have the last fitting that we'll take a look at, which is, of course, the plug. This is the 9th fitting in the range at the moment. And this is also a single part base, but it comes with the same cover that the Rotaries have. So you have a cover for the hexagon socket. It has a hexagon socket cut both into the outside and the inside. So you can see the key engages on the inside of the plug and the outside of the plug. There's not many places that you'll get the chance to use that. But if, for example, you were in very close quarters in an SFF build and you tried to put this on a terminal of a GPU block, you could put the key from behind through the terminal and rotate it backwards and screw that down onto the terminal, which is quite practical. You may want to use it for bleeding, or if at some point in time you find yourself getting it stuck and you don't have access to the front side, but you can take things apart and unscrew it from the back. Very practical just to have it there. The aesthetic cover is exactly the same and completely interchangeable with the one from the 90° and T fittings. And that rounds out the 9 fittings that we have at the moment. Upcoming fittings that we intend to launch are a male-male extender with a rotating component so that you can install it between 2 female parts. If you would have, for example, a flow meter or a drain valve or such other component, you could have that rotary joint put together. It will probably be 7mm long. That's the shortest we could make it. We're trying to make things as small as possible so you can combine them in as many ways as possible. After that, we will make a drain valve. I'm not sure exactly what configuration of drain valve it will be at this time, whether it will be a ball valve or a sleeve or some other combination that would be even more useful. And following that, also a female-female version of the 90° fitting. So the one that we saw has a male base. We would extend it and have a female base. And in that way, you could join 2 90° fittings, the male version and the female version, together in the middle and make a 28mm offset that can rotate on both sides. So you could effectively make little distribution plates from them. If you would route your tubes out to a panel, have that behind it, and then come back through. So that's the next part we're thinking of. I did promise I would show you installation of these fittings. So to help me, I'll use this micro block. I'll build some combinations that you're most likely to use and put the tubes on. We'll take a look. So to show you as many fittings as possible, I've decided that we'll combine these. There's a male-female 7, male-female 28s, and 3 male-female 90° rotaries. We're going to use the 28s at the bottom to bring up the height because the micro is quite small and we need to go over our RAM. I'm going to make on one an offset of 7, and on the other it will just go directly parallel out. So then our tubes will end up being about 56mm apart. So first, one extender. And these don't need to be really tight because remember this is plexi and for sure it cannot withstand as much force as the fitting. So I'll just be gentle and use the short end of the hexagon key. Next, I'll remove all of the covers. And start to install these. So one we'll put here and tighten that down. The next one here. I Remember also, if you spin this and really tighten it, you will also spin the base and in turn put the force onto the plexi. So once again, not too much force is required. This one is much safer because it will be brass on brass. So we put the 7mm in the middle so that we have a 28mm offset to the last rotary fitting. So there we have all the rotary fittings installed. You can see they all have complete freedom to move wherever they would like. And I will put back the aesthetic covers. I'm going to put them so the logo is perfectly horizontal. You can put them in any orientation you would like, and you can see when they're on there and you move the rotary part, the cover actually stays in place because it's connected to the base. And there should also be space for one more on the end. And now we need some tube fittings. So we have one ST16 and one HT16 because conveniently I have only one soft tube and one hard tube. If I cut this in half, it will be quite small. So first we'll separate the compression rings, and I think we'll put the soft tube onto the essentially not offset one because it could flex anywhere. Tighten in the base with the hexagon and put the compression ring over the tube. Now this should be much easier than earlier because it's on a fixed object. And tighten the compression ring. By this point it will already be pretty tight, but they can go all the way down. And there you have it. That should secure the tube very nicely. And we'll do the same with the hard tube fitting. If you remember from earlier, this has 3 parts. The same compression ring as this, the O-ring and the base. So it doesn't actually matter if you would mix up the compression rings from these two different fittings. They're all identical. So there we go, that's the base installed, and I will get the tube, which is inconveniently long. There's the compression ring and the O-ring. You'll notice this tube is not chamfered at all. This is just clean cut. And you'll marry that up to the base of the hard tube. You can see the diameter of the little boss that sticks out matches up to the diameter of the tube, and the O-ring slides over and will just hold them in position, and that will center things for when you bring in the compression ring, and that just slides over both and you thread it down. It makes about 2.5 rotations if I remember, and just like the soft tube, should be able to rotate all the way until it makes contact with the base, and then the tube is securely attached. So there we have it, our funny little loop example. And hopefully in the future, I can show you in a complete build when we have some more DeltaMate products. So come back for those. I think next up will probably be the RTX Astral 5090, or the Astral RTX 5090, as I should have said. And shortly after that, the MP2 AM5 block, which will be a CPU block. So, thanks for looking at this in-depth video. I hope you enjoyed it. Let me know if you prefer the short video, the long video. If you want to see even more details, maybe we should go and check out the machines and the equipment where all this stuff is made, or maybe take an excursion with Roman. Let me know what you think, and I'll see you in the next video. Bye.